My name is Wendell Edwards, and today we will be looking at factorizing polynomials by 1. Using the highest common factor method, 2. Grouping method, 3. AC method, which lends itself to what we call the difference of two squares in a special occasion. Let us start off by looking at this problem. Let us say we have a 3x plus 3y. First thing we do whenever we are trying to factorizing any polynomial is to look first to see if there is one thing common for all the terms. So we have two terms here, 3x plus 3y. If you look carefully, we'll see that the 3 is common for the x and it's also common for the y. So this is our highest common factor. So we will employ the H.C.F method here, highest common factor method, highest thing that is common. So we isolate the common factor, then the process is that you open a bracket. What we're about to do now is to divide the highest thing that is common throughout. So we're going to divide it with this term. You could see that it cancels, leaving an x, we represent that. We're still going to divide the common factor, which is 3, into 3y. It cancels itself, leaving the positive y. And here we have it. The factor for 3x plus 3y is 3 into, or you will say times, x plus y. Let's look at another situation. All right, let's look at 15x square y minus 20xy square. So looking at this, again we'll ask ourselves, what is common? And when we speak of common, it may not be visible. It may be something that can be divided into the terms. So for the 15 and the 20, 5 is a common factor because 5 can go into the 15, 5 can go into the 20. And this is actually the biggest number that can go into the 15 and the 20 without a remainder. So that the 5 would have taken care of the coefficients. Now, if you look, we have an x that is common, a y that is common also, because we have xy here, we have xy here. The beauty is that whenever you're using the letters, we have to look to see the lowest power of the letter. That's what we want to use to divide throughout. So in this case, the lowest power of the x is x, and the lowest power of the y variable is the y. So that means we're going to team the 5 with the xy. Open the bracket. What is going to happen now is that we're going to use the 5 to divide throughout. So the 5x, you're going to use that to divide throughout. 5xy, I should say. So the 5, we're going to use of 1, the 5 into the 15, 3. The x would have cancelled one of that, leaving x, and the y cancels all. So right there we're left with 5 into 15x squared y, the 5xy, I should say, into the 15x squared y, we have 3x. Similarly, we're going to do the same thing here. We're going to divide the 5xy into that. The 5 would take care of the negative 20, so we have a negative 4. The x cancels itself, and the y into the y squared, leaving y. So there we'll have it, the factor. So if we should factorize 15x squared y minus 20xy squared, the factors are 5xy into 3x minus 4y. So basically that's one case looking at using the highest common factor to factorize polynomial. Let's look at a case where we're not seeing anything common throughout. For example, we see a case where we have 6p minus 9 qs plus 4 q minus 6 qs. Now, if we look at this one carefully, we are seeing where we have 1, 2, 3, 4 terms. If we look throughout, we can't find a number apart from 1, because 1 is always a factor of everything. So let's look carefully throughout. We're not seeing where only 1 could go through, so there is no other number that is common for everything. 2 could work for the 2, for the 4, and the 6, but it can't work for the 9. 3 could work for the 3 and the 6, can't work for the 4. That simply means then that we don't have a common factor, because we're not seeing a letter that is common all the way, because the P will only work for part of this, right? The P would only work for part of this right here, and the Q will only work for right there. So it's not common all the way. And the S only for here and here. So basically it can't work. So whenever you find yourself with 4 terms and there's nothing common throughout, what we do next is to look to see if we could find pairs with common factors. For example, look at this pair here. We're seeing that 3 could work for the 6 and the 9, and P could work. So this is my first pair. Let us look at this one here we're talking about right here. So we're looking at the fact that 2 could work for the 4 and the 6, as well as Q could work. So yes, for the second pair, we have something that is common. So normally when you pair them up, if you find things common for both, then yes, it could work. So let us look. I'm going to take up my common factor here, which is going to be 3p. So I will be factorizing them in pairs. So for this pair, 3p, we're going to divide 3p. We will divide 3p into this. And 3p into 6p, 3, 2p cancel p, we're left with 2. 3p into negative 9ps. 3 into the 9, that's 3, then this is a negative 3. P cancel p, leaving s. So let me write this a little bit better. Minus 3s. Alright, 3s, not 35. This is 3s. Let me write it a little better. Alright, so good. So the thing now, the catchy part of this is for the next pair that you're going to do, you will have to make sure that you choose the right factor so that when you divide it throughout, you will get back a bracket like this. So I'm seeing where there is a 2 and a Q. Now I will be using positive 2Q. And why am I using positive 2Q is because if I use negative 2Q and divide negative 2 into positive 4, I will get a negative 2. And I don't want a negative 2 because this 2 is positive. So I have to make sure that the factor I choose when I divide, it matches that. So in this case, we're looking at 2Q. If I should divide the 2Q quickly, 2 into the 4, you could see that is 2 times, and Q cancel Q, that's gone, just like this. Let me go again, the 2Q into the negative 6x, S I should say. 2 cancel into itself 1, and then it cancel into the 6 3 times. So this is negative 3, and then nothing is in the Q, cancel for the Q, leaving the S. So you could see here where this bracket is exactly like this bracket. Now, when you're factorizing by grouping, you're going to realize that you will do double factorization, because if you notice, there is a common factor again. And whenever we factorize properly, we're expecting to see 2 brackets beside each other, or one term with a bracket. In this case, we realize that we still have another thing that is common. And this thing that is common is the 2 minus the 3s. 2 minus 3s. So it is now my common factor. So I will now go back and use my highest common factor, which is, in this case, it is the 2 minus the 3s. That is the common factor. Now it is a bit big, so just work with me. What if I should use this to divide into? If I should use the 2 minus the 3s to divide into this, it will cancel. So we'll have the 3p, and if I use it to divide into this, it will cancel. And then I'll have my 2q. So normally what we say is, as soon as you realize that this bracket is identical to this bracket, then you could write back this bracket and put the other two things in the other bracket. So that is factorizing by grouping. Thank you. Watch more because we have more coming.